See this, least upper bound. So LUB or join or supremum. Now how to find out this least upper bound is, see, I'm going to give you the definition, but then we are not going to use these rules. We can use the other methods to find out. So most of the questions asked on this will be on the standard examples. So I have taken the standard examples and I explain you, but still I'll read out the definition and I explain you. See if you can understand it. Otherwise we are not going to use it anyway. Try to understand it better. Okay. So if A comma R be a poset, what does it mean? A is a set and R is a relation on the set, which is partially ordering relation. Okay. Now if you take any two elements that belong to A, if there exists an element C such that, so from this you should understand that if there exists an element, which means there is no need that it should definitely be there. In case if it exists, then only we are going to talk about it. Therefore, what should you understand is, least upper bound of two elements may exist or it may not exist. In case if it exists, we are talking about it. Okay. Now see this. Then if it exists such that both A and B should be related to C. So what I mean by this is, you should have the elements A comma C and B comma C present in the relation, right? And once you have such a presence, then there is a chance that C might become the least upper bound. But there is one more point. So there might be more than one element which might be related like this, which means you might have A is related to C, B is related to C. Similarly, A is related to D and B is related to D, which means you have two elements now, C and D, which are both related to A and B. Now, which among these two are you going to take as the least upper bound? So, for that reason, see this. Now, if there exists any other element D such that A is related to D and B is related to D, then C should be related to D. Then C is called least upper bound of A and B. What is the meaning of this one is, in case if you have more than one element related, then you take the lower of them, right? Which means a element which satisfies these properties is going to be least upper bound. So I think what you should catch here is, first of all, if an element has to become the least upper bound, it should definitely be related to both the elements, and in case if some other element is also related to both of them, then this element should be related to that. Got it? So it is bit difficult to understand about it or even find out the least upper bound by just looking at the relation. It is better if you can draw it in terms of the diagram. That is why I am discussing diagram first and then these definitions. In most of the textbooks, they define the definitions and then last at the end they will define these diagrams. But having these diagrams will help you in finding out it very easily. See this? Now, if you take this, okay, this is a special example, we shall see it later. Now you just take this one. If I have A and if I have B, what do you think will be the least upper bound or join? So just by the name, it is sometimes called as least upper bound or join or supremum. So why is it called join is, both of them are going to join at this place, right? Therefore it is A comma B will be least upper bound. In fact, see, from diagram it is very easy to see that A comma B is the least upper bound of A and B. If you take these two elements, what is the least upper bound? A comma B. From the diagram it is clear, right? You can visualize it, and you can even see that we got this answer not just from the diagram, but because it is satisfying the properties. What is the property? You have the elements like this present in the relation. A comma AB are present in the relation, and similarly B comma AB are also present in the relation. Because of the presence of this and presence of this, and there will be no other element to which both A and B will be related, right? So you have phi, but then phi will be related like this, which means phi is related to A, but A is not related to phi. But here A is related to AB and B is related to AB. Since both these elements are related to AB, that is where the condition A, isn't it? And anyway, condition 2 is not applicable because there is no other element to which they are related. So what can we say? We can say that AB is the least upper bound or join or supremum of A comma B. Now for these two elements, it is very clear you are able to find out. What about if I want to find out the least upper bound of a comma phi, what can you say about it? These two. So if you see this, if I see these two, they both are going to join here itself a. Therefore, least upper bound of phi and a is a itself. So how did we get it? Because in the relation you will definitely see the elements like this. One element is a and a. Why? Because of reflexive property, right? A is a subset of a. Therefore, a is related to a, as well as you will see phi and a. Right? Therefore, phi is also related to a. Both these elements are related to a, isn't it? And are there any elements that these both are related? Yes, there will be one more element. These both are related. What is it? A is related to AB, and then phi is related to AB. The reason is A is subset of AB and then phi is subset of AB. Now in this condition, in this case, you have found the element C to which both are related, as well as you have found the element D to which both are related. Now which one should be the least upper bound? Then the second rule comes into picture. See this, we have found an element C to which both are related, as well as we have found an element D to which both are related. What is C? C in this case is A and D is in this case is A comma B. Now which one is going to be the least upper bound? So for that reason we are going to apply this rule. So what is this rule? Even though C and D are present, we already have one more relation. What is this? A, C and D are related. Therefore, we can directly take C as the minimum. Least upper bound. Therefore, in this case, the least upper bound is going to be A itself. Are you getting this? Both phi and A are related to A as well as AB. But since A is lower than AB, then we are going to take phi as the A as the least upper bound. So just think about it. When you have many elements related to like this, let's say, what I mean to say is like this. If there is an element here and there is an element here, these two are definitely related to this. Therefore, this one, there is a chance that it is going to be upper bound, as well as if you have one more element here, these two are also transitively related to this element. Therefore, it is also going to be an upper bound. Now, whichever is least, which means this one is going to be the least upper bound. So what we are actually trying to do is, if we have two elements, we are trying to see what is the least element possible which is above them. That is why it is called as least upper bound. Therefore, when I take phi and A is the least upper bound to both of them. Yes, AB is also an upper bound, but then the least upper bound is phi. Similarly, if you take phi and B, then the least upper bound is going to be B. What about phi and AB? The least upper bound is going to be AB. Got it? Okay, now you can think about this one here. See, if I take 1 and 2, what is the least upper bound of 1 and 2? 2 itself, right? If I take 2 and 3, what is the least upper bound? 3 itself. If I take 1 and 3, what is the least upper bound? 3 itself, which means we are talking about what are the elements which are above these two in such a way that they are going to be bounding them. So 3 is above them as well as 4 is above them. See, if you take 1 comma 3, both 3 is above them. See, what I mean to above them is by this relation less than or equal to. 3 is less than or equal to 1 comma 3 as well as 4 is less than or equal to 1 comma 3. But 3 is less than or equal to 4, which means least upper bound. Therefore, in a relation less than or equal to, when you are talking about two elements A comma B, then the least upper bound is going to be maximum of these two, which means if I have elements 1 comma 2, then the least upper bound is going to be 2 here. If I have elements 2 comma 4, then the least upper bound is going to be 4. The reason is whichever is maximum is going to be the least upper bound. And in this case, in case of the set inclusion relation, which means subset relation, then union of two sets is going to be the least upper bound, which means if I take A and B, the least upper bound is going to be union of these two, which means A comma B. If I take phi and A, the least upper bound is going to be union of these two, which is A. If I take phi and B, the least upper bound is going to be union of these two, which is going to be B. Got it? So you can take it and see it. So in less than or equal to, always least upper bound is going to be maximum, and in subset operation the least upper bound is going to be union. And now let's see this type of set. So this is a different kind of set. D18 means it is set of all numbers which divides 18, right? So all the divisors of 18. So 1, 2, 3, 6, 8, 9. So that is called as D18. Now on this D18, if you define the relation divides, then it is going to be a poset. These two. This is the poset diagram. Now here, let's see what is the least upper bound of each element. See this? If you are looking at the least upper bound of 2 and 3, where are they going to meet? They are going to meet here, right? So it is the join of them. So we can say that 6 is the least upper bound, right? What about 6 and 9? 18 is the least upper bound, right? What about 1 and 2? 1 and 2, least upper bound is 2. 1 and 3, least upper bound is 3. Now in case of divides, in under the set Dn, always the least upper bound is going to be LCM of two numbers, right? If you want to find out LCM of 6 and 9, it is going to be 18. Therefore least upper bound of these two is going to be 18. See, it so happened that LCM is here, the least upper bound. It is not a rule. So actually we defined the least upper bound from these two rules, and then when I observe these examples, then I'm seeing that there are some properties. In this case maximum, in this case union, in this case LCM, right? So if you find out the LCM of 6 and 9, then the LCM is 18. That is how I got it. Now what about least upper bound of 6 and 18? If you find out this, the LCM is going to be 18. Therefore least upper bound is 18. Got it? And then 1 and 2 like that. So we, as and when we see more and more examples, I'll again explain you how to find out the least upper bounds. Okay? Fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.